In this video, we're going to look at some ideas that are out of this world. We're going to look at circular orbits of planets, velocity, speed, and orbit radius. First of all, let's learn the difference between velocity and speed. Which of these measurements tells us a velocity? So how is velocity different to speed? They both contain information about speed. Velocity is speed in a given direction. On a fairground ride, your speed and velocity will keep changing. What about an aeroplane doing a loop-the-loop? The plane may be moving at a constant speed, but because its direction is constantly changing, its velocity will also keep changing. A change in velocity results in acceleration, so an object moving in a circle is accelerating even though its speed may be constant. So what does speed and velocity have to do with planets? Most planets have nearly circular orbits around a star. So the planet's speed will remain constant, but because the direction changes, so does the velocity. To make this clear, think of a football player trying to turn. She digs her foot into the ground to provide the force to enable her to change direction. If the ground is very wet, her foot slips and she carries on in a straight line, in a skid. So for an object moving in a circular path, there has to be a constant centripetal force which acts towards the center. Look at this car on a roundabout. Here, the tires grip the road, providing the force to enable it to change direction. On a wet or icy road, there is no turning force, so the car goes straight on in a skid. Gravitational attraction provides the centripetal force needed to keep planets and all types of satellite in orbit. Try swinging a ball attached to a string around your head. The string pulls the ball into the circular orbit. However, if you let go of the string, no more centripetal force, the ball just continues in a straight line. Now, think of you as the sun and the ball as a planet. Without the force of gravity, the planets couldn't stay in orbit. The gravitational attraction between two objects is greater the shorter the distance between them. If the force between them is greater, then the object must move at a higher velocity to balance the higher gravitational attraction. Otherwise, the planet will spiral inwards and crash into the sun. This means that objects in small orbits, such as the inner planets Mercury, Venus, Earth, and Mars, travel faster than objects in larger orbits like Neptune or Uranus. Now, isn't that all out of this world? Get it?